welcome each and every single one of you. Hopefully the others, if there are some out there still, that they'll be able to pop in. For those of you who I have not met, my name is Brian A. DDA. I put my Boeing email there for you, so if you have questions or something during as we go through here, you can feel free to send me an email, or you can use the chat box. I do keep the chat open so that I do see the questions come in sometimes. So if you hear me go silent for a moment, I'm probably checking that. If, as my previous students know, they also know me as Mr. Bad. So if you look at my initials, my full name is Brian Alexander DDA. And if you put my initials together, you see that it is BAD or bad. The story behind that is one amusing story is when I was in the Air Force, back when I was 19, 20, 21 years of age, I was stationed in the Philippines, and all of the jet engines going through I ran the engine test cell, jet engine test cell. So all of the jet engines going through there and then getting installed in the airplanes, the pilots would come and they would pull the cord doing the pre-flight. They'd pull the aircraft records out, get to the engine portion of it, and they would see something. Giles, Dominic Gideon cannot log in. Alan? Hey, Alan?
Yes. Okay, I'm going to have a quick look.
Okay, yeah, it's in the chat message there.
Oh, okay.
So anyway, when the pilots would grab his record, he'd get to the engine section and he would see things such as engine fuel filter bad, oil filter bad, engine fuel control adjustments bad, and he would close the book and not fly again, or not fly the airplane. I got a letter from the 4-star general in that area telling me to use BD. So that got kind of amusing. I've been with the Boeing company for 35 years now. And then, of course, about 11 years in the Air Force. So, and all of it has been on the airplanes, of course. Most of my 35 years with Boeing have been on the 737. Raja, yeah, yeah, bad login. Huh? I like it. So that's who I am. Let me just move this off to the side here. So we have that. I don't know if you can see that, but those are my two lovely granddaughters. They are. This one is Naomi. She is 6 years old now. And this one in the background is Tiffany. Tiffany is 5 years old now. So Tiffany right now is also here in Palm Springs with me. So she is, we have a swimming pool here, so she's always in the pool. So anyway, but this is our schedule for today. And hopefully you can see it. So what we're going to cover, what we're going to review is going to be the power plant. So the power plant will look at the LEAP engine, the electrical, and the fuel system this morning. So that will take us up to lunch. Then we'll take about an hour, 45 minutes to an hour for lunch. And then at the rest of the day, we'll go through the hydraulics. And now when I say hydraulics, it's going to be hydraulics, landing gear, and the flight controls. We'll cover that, all the bits and pieces there. And then we'll finish up the day with ECS. And the ECS is going to be actually pneumatics, air conditioning, Um, um, I just lost my train of thought. I glanced over here and somebody asked if
Pressurization.
yeah, but I saw a chat message there. But anyway, pressurization, there's no change in it, so we won't really cover any of that. We'll get into wing and engine anti-icing, smoke, the equipment smoke portion has changed a little bit. And then just the small bits and pieces that potentially would be there. There's about, like I said, about an hour worth of stuff there. So that's what we're going to be looking at, okay? Let me move this over and we will go ahead and get started. And hopefully all of you are able to see that. So electrical power on the 737 MAX. Let's see, to Mr. Hey, Alan, could you look at the chat message also? Mr. Ural is waiting for joining, so I think he needs the email also. Thanks,
Okay.
Edward. So the MAX, the electrical power system on the MAX, no real change on the MAX. It's essentially exactly the same that you have on the NG, that you experienced with the NG. With the bits that have changed with the MAX is really the air oil coolers. Okay, there is no fuel cooled oil cooler on it anymore. That's removed from the system. We have the two air oil coolers. These coolers are going to be located in the lower portion of the LEAP engine fan area, okay? So they're going to be down in that section of it. So that's what this is the outer casing of the fan on that side. So when we look at where they'll be right here is the access point. To access them, you're going to have to open up the fan cowling, and then you'll also have to open the thrust reverser cowling on that side. They're fin-type surface coolers. So what that means, of course, and you can see them right here, going to be located right in the left and right portion of the engine on the fan. But since they are fin type coolers, they are easily damaged. So if you're having to work in this area for whatever reason, highly recommend that you put the protective covers that go with the system on there so you protect the fins. There is some small allowable damage for the fins, but very little on it. You'd have to follow the AMM to check on it. To check the fans to see if there is any damage, what you're going to do is open the fan cowling, the thrust reverser cowling, and then take your flashlight, your torch, as you in England call it, and hold it right in front of the fins, the cooler's fins facing towards you, and then you're able to look through that piece to see if there's any damage on that. The AMM does tell you that you can, if you have a fin that's bent a little bit, the AMM does say that you could try to bend it back. However, be extremely careful because you're probably just going to break the fin off and then you'd have to replace the cooler. So just be careful in that particular area. To remove and replace the cooler, obviously what you're going to have to do is open up the fan casing, the thrust reversers. You have the two connections right here. And then on the inside, there's going to be a little plate on either end that holds the ends of the cooler down in place, okay? So you just have to look at that. So that's the change as far as the electrical system. Nothing electrical in it other than the cooling portion of it. Other than that, it works exactly the same, like I said, as previously. The fuel system, not a lot of change to the fuel system as we go through it. Get this back right there. Really what we did is the boost pumps that were on the forward portion, on the forward spar, we relocated them to the rear spar of the wing. Okay, so all the boost pumps are going to be in the rear spar of the wing. So we have your aft boost pump and your forward boost pump located in this area right here. And the reason why they got relocated is because of the engines. Okay, they were excuse me. Because of the new larger engines, the turbine disc burst area was in that particular area. Okay, so at the turbine burst, they would take out the pumps. So because of certification requirements, that's what caused the pumps to be moved. They're still essentially the same. The boost pumps in the main tanks 1 and 2 are interchangeable. The main tank boosts are not interchangeable with the centered pumps. The other thing that's changed, the indications, really, you have an option. You can have either digital like that or representation of an analog display. The messages are all still the same. You do have a new one that's going to be on the fuel indicating display that just says fuel flow. Fuel flow is when it's a disagreement between what the FMC is looking at versus actual fuel flow that the engine electronic controls are looking at. Okay? The fuel quantity processing unit, it's a different fuel quantity processing unit. It was redesigned to account for relocation to the ceiling of the forward cargo compartment. So we moved it from the forward equipment bay area to the forward cargo compartment. So if you open up the cargo door, the forward cargo door, and you're looking inboard into the cargo compartment, and on your right side, if you raise your right hand up and over to the ceiling, you're going to be pointing to the FQPU, the Fuel Quantity Processing Unit. Okay. New software is also added into the pump, basically because the new 615 bus that you have. So if we look at it, also our wiring harness has changed. Okay, the harness, not necessarily totally different, but basically the busing plug, we moved that. It used to be mounted right outboard the engines, but we put them in the hole where the boost pump was moved from. So that's where the busing plugs are located now. Okay. The fuel quantity processing unit, all the byte on the fuel quantity processing unit is still done through the CDU area. So that hasn't changed at all. What it does is still the same. It's going to calculate the fuel weight. It's going to send the fuel weight out to the FMC, your P15, and the display processing computers. It's going to collect and monitor all the faults. Okay. Now, the faults are going to be the same way that you find them in the NG. Okay, through the system, through the byte, through the CDU. However, you should have, when Alan was going through the ONS, he would have covered this particular page. But one of the things that's here, the network file server, And if you notice right here, we have the fuel quantity processor right in that area, same area, along with other boxes. Well, the fuel quantity processing unit shares its information with the network file. It goes to the digital flight data recorder. And since the digital data flight, the DFDAO shares its information with the network file server, what that means to you as technicians is that you can open up the onboard maintenance system, go to the existing faults in the extended maintenance page. You can go to the existing faults or fault history, and you can see all the faults that the fuel quantity processing unit may have. So you have a choice. You can either go through the CDU and go one by one through that, looking at all the faults, or you can open up the onboard maintenance system and see all the existing faults also. So just a little something that you can see. And that's going to be true of all of the boxes that you see located on this general description page. The cabin pressure controller, ACARS, the FSEU, the ADRU, the flight gas, the fire detection control unit, all of these items are going to be that same way. So just wanted to make sure you knew that. So that's really the fuel quantity processing unit. So not a lot of change. Let's see, if you have a problem with fuel tank, will those new appear on the display since we're not receiving correct information from the Alberto. If it picks it up and sets it off as a fault that the FQP is sensing, then you would see it. But it comes off. All the maintenance messages will come from the fuel quantity processing unit. Okay. The APU.
Hey, Brian.
Yes, sir.
I'm sorry. I guess this question is, because you got tank 1, tank 2, and center tank, if like tank number 1 dashes out, because, we've seen that before on the NG airplanes. You get your new messages, which are your fuel, your insufficient fuel, fuel reserve, fuel disagree. So if one of your tanks, tank number 1 goes dash and you see center tank and tank number 2, you're not getting the information. Is that going to cause any of those insufficient fuel reserve or any of those indications to come up since we're not getting all the information? Our flight crew is going to see that if we MEL any of the tanks?
That's a good question. Let me, I'm not sure, so let me find out from Seattle and I'll give you guys back a question. If I don't get the answer back from them today, since I have all of your emails, I will email you that answer.
Thank you, sir.
My pleasure. The airborne, the APU. The APU that's going to be located for the MAX, it's a Series 41 APU, okay? So you can only use a Series 41 or higher on the 737 MAX. My iPhone decided to start talking to me. So what we have is on the APU, only the Series 41 APU can be used, okay? The Series 41, there is a service bulletin that is out that allows you to change your Series 8 through 40 APUs into a 41 series APU so that you can use those ones also. But you need to go ahead and use that service bulletin to do that. Really what the change is, since the mounting and the placement of the APU is in a slightly different way, and the mounting a little bit more heavier in that portion of it, okay? The APU itself, excuse me, the APU placement and everything, the The output of the APU is still essentially the same as you have for the as the NG. What we have is a new, longer aerodynamic tail cone, which means that the exhaust area here is going to be a heavier exhaust. Okay. The APU door, it's a new inlet door, 28 volts DC actuator that's going to be driving it. It's going to be moved into 3 different positions. It's either going to be closed, open at about a 45-degree angle on the ground, or if in flight, it'll be open about 17 degrees. So those are the 3, excuse me, 3 positions that we'll have as far as the APU is concerned. And we'll look at that in just a moment too. The other thing that is different on the NG, we no longer have that eductor ducting for the cooling side. Cooling does go around inside the APU, but the ducting has changed there. Controls and components, same controls that you had on the NG. Okay, same controls. Location of them are all in the same basic area. What has changed, of course, is going to be our control panels on this. So if we look at that, on our sys control, this is our APU area here. If we look at our controls, you still have the APU switch, same APU switch, but our indications have changed a little bit. We have a amber door light now. The low oil pressure light fault in the overspeed. The blue maintenance light is removed. The blue maintenance light is removed. Why? Because all the maintenance messages or those things are going to become maintenance messages in the OMF, and if it becomes a status message of some sort, then it's going to illuminate or be shown on your status message page, and then, of course, illuminate the maintenance light also. Other than that, everything else is still the same. Starting the APU is going to be exactly the same as you do on the NG, okay? Same as you do on the NG. The only thing that you're missing at this point is going to be the EGT gauge that was also on this panel. The EGT gauge is now on the APU data, maintenance data pages. Okay? So the only indication that you have is going to be the low oil pressure light, and it's going to go off after a few seconds when you start the APU, and then you'll get the generator bus light come on when it's up and running. Okay, so pretty much the same. If you wanted to watch the EGT and monitoring it, if you had ground power on the airplane and you had the system powered up, you could in fact open up the data pages and go to the APU data page and watch the EGT there. I mean, you do have that option. Okay. Shutting the APU down, same way you do with the NG. Okay, same way you would do with the NG. Make sure that you do not use the battery switch to shut the APU down. You use the APU switch. Why? Because we have to go through that 60-second or that 60-second cooling for the APU that the ECU is going to do. Okay, if you go through the battery switch, you bypass the cooling section of it, and you'll potentially damage the APU. The other bad thing about that is that's recorded in the DIM that the APU has, and if the APU got damaged, then you went back to Honeywell that says, hey, my APU is not working. It's damaged. I need a new one. Well, you had voided your warranty. Okay, so make sure we shut it down properly. Okay. The APU inlet door. The APU inlet door, it's going to be, you have the APU inlet door, and then you're in the access area there. It's going to have, if you're looking at the back side of the APU door, you have the actuator. The actuator is going to be inside of this silver can protecting the actuator. Right on the edge of the door is going to be an inlet door open switch. The open door switch is what's going to monitor when the door is open or closed. Just looking at that. There will be another set of switches inside the actuator that is going to be monitoring how far the door is open. Is it that 45 degrees or 17 degrees, or is it closed now? So we have those areas, okay? So this is a little bit more of you, a little bit closer, so you can see the air inlet door switch right here. This is the actuator right here, and then there's also a rod that's sticking out here. It is possible to manually open and close the door if you need to. Let's say that for some reason the actuator has failed and you need to be able to run the APU in flight following the procedures for the MEL. It's going to allow you to open up the actuator door. It'll take two people, one that's going to essentially follow the instructions and using your tool to drive the door open, another person on the outside of the plane to measure how far that door has moved. Okay? But it is possible to do that. Inside the OMF portion of it, in your maintenance control pages, in your miscellaneous system controls, you have the ability to power up the engine control, the APU ECU portion of it, okay? What that's going to do is allow you to do the bite test for the APU, okay? The APU does the bite test whenever the ECU is initially powered up, and you can power it up through either the soft switch here in the control pages for test, or you can turn the switch on up on the P5 page, either one of those two areas. Okay? The data pages, as Alan went through with you yesterday, going through the maintenance data pages, display selection, and then if you go down to the APU, chapter 49, and if you hit the display selection, that's going to bring up the data pages for the APU. Okay, on the data pages, what you have is the mode and the generator load, RPM, and EGT, oil temperature, oil quantity. This is where you're going to check the oil quantity. It's going to be either full, add, or low indication. You have to have the APU ECU energized in order to have that quantity there. But that's going to tell you the quantity of the oil. The inlet temperature, your load compressor, your IGV activators, fuel flows, the inlet door position, corrected EGT, total pressure, fuel flow, and your EGT position. Typically, your corrected EGT is what you're going to be used for monitoring trend analysis. APU hours, your APU cycles, and hours since installation on the airplane. The bit information down here is information that goes to Honeywell on it, okay? Starting as fuel pump, mandatory, saying exactly, correct to be turned on to start the APU. So it's not in the sequence. What you have to do is, there's a question, is in regards to the APU starting sequence, is the fuel pump mandatory or correct to be turned on to start the APU? When you go through the AMM and in the start procedure, it has you ensure that you have, of course, the proper amount of fuel in the fuel tank. But yes, you go ahead and turn the pump on so you have proper flow on APU. This is the data page that when you are starting the APU, like I said, if you had power on the airplane and the DPCs were powered up, you could come to this page, display it, and you could have this on the display pages as you're starting the as you're starting the APU, and you can monitor EGT right here if you so desire, okay, on that. And then you'd also see fuel flow and the position of the door they go through on that. Just like Alan said, if you were actually monitoring some things, you're troubleshooting, you could in fact come down here and record the data page if you so desire, if you were looking at for something. Okay. A lot of information available to you today on the MAX that you did not have available to you previously. In our onboard maintenance section, other functions, special functions. Okay, you have special functions. When you select it, you'd select the APU auxiliary power system, and then you'd have there are 3 system functions that you are able to select. 3 system functions are going to be reset hours since installation. So when you install it, you could reset the hours on the inside the OMF on the data page. You have a limited restart section. The limited restart is if the APU did a protective shutdown for some reason, some of those items are going to cause or be latched inside the ECU, and you would have to come right here to clear that piece after you fix the problem to be able to start the APU up. Okay? The ice break logic is it's an on-off essentially. So you can turn it on if you need the ice break portion of it, or you can turn it off for the inlet guide. What ice break logic is that when it's on, the system is going to periodically sweep the APU IGVs to ensure that there's no ice on the APU IGVs. Okay. If you turn it off, you just removing that logic so it doesn't work. Okay. When it's on, it works automatically. What the ECU is looking at is what's the temperature. If it's near freezing, then it's going to sweep the IGVs. Okay? So some of you may not be flying in an area where this would be a problem. Some of the rest of you may be flying, but this is a choice that you can do. Okay? That's really the APU. The controls on it, like I said, is very similar. You do not have the maintenance light anymore. You do not have the GT gauge on that piece, but the operation of it is still pretty much the same as you have. Okay. The LEAP engine. The LEAP engine. Obviously, the LEAP engine is a new component for us. Okay. It's a much larger engine than we have had in the past. LEAP stands for Leading Edge Aviation Propulsion. Okay, and what we'll cover is we're not going to get into all of the ATAs that cover the engine because some of them are very much the same as the NG. But we'll spend until lunchtime on the power plant at this point. Okay. The engine itself, if we look at our components on the left and the right side of the engine, we have on the left side, up on the top here, this is our main fuel oil heat exchanger, and this is the fuel metering unit. okay? The fuel metering unit, and then on the core engine, the split control unit. On the CFM engine, that was that hydraulic fuel control unit, okay? The HF, HM, and U. So on the LEAP engine, essentially it's split apart. You have the fuel metering unit on the left side of the fan case and the split control unit on the core portion of the engine on the left side. Also down the left side of the engine, the accessory gearbox. On the accessory gearbox, on the front side of the accessory gearbox, we'll look at the starting piece, that starter motor down in the 6 o'clock position of it. And this is the starting ducting for the pneumatic system going to the starter motor. Ignition boxes are going to be located at 6 o'clock position under the engine. We have 2 drain masks, one for the fan case, one for the core engine portion of it. The high pressure turbine and low pressure turbine active clearance control. We're going to pull in fan air and then through our 2 valves for cooling of our dust. The components that we have right here, the inlets, that's all of your variable bleed valves. There's 8 of them around the side of the engine. We look over on the right side of the engine. On the front, on the right fan cowl, we have the engine electronic control, channels A and channel B. Okay. On the NG, you had a single box, but there were still 2 channels inside that single box. Basically, these are split apart for space. Okay, really the only reason on that. If you look below channel B, there's another box here. This is your pressure subsystem. Pressure subsystem is going to take air pressure from around the engine, and it's also going to have the engine data plug installed onto it. But it's going to convert all of that information to signals, and it's going to share that information to our engine electronic controls, channel A and channel B. On the right side of the fan case, towards the aft portion of it, is the oil tank. The oil tank is kind of like a sausage, so I've had some of my students refer to that as a sausage there, just because it's long and cylinder. The pneumatic system components are going to be located on the right side of the engine. On the CFM engine, it was on the left side. So this is all of our air conditioning, our pneumatic bleed ducting. This is going to be the high pressure shutoff valve. This is the pressure regulating shutoff valve, and the check valve is located right here. This tubing here is going to come on up and up that center piece of the engine right here, that center frame piece, and that's where the engine anti-icing valve is located. And that ducting is going to continue on to our cowling right here for engine anti-icing for the nose cowl piece. Controls for that portion, these switches right here are for the engine anti-icing. We'll look at that when we get into wing anti-icing. Okay? So that's the basic components that we're going to look at as far as the engine. Danger areas, hazard areas of the engine. This engine is much larger than your CFM engine, much larger. Make sure that you provide the appropriate caution when you're working or you're around the engine. There is absolutely zero safe area in anything other than idle. Okay, if there is no safe area. The inlet hazard area is a larger inlet hazard area because the engine is larger. At idle takeoff, the NG was only about 4 feet on the LEAP engine. It's increased to about 4.5 feet or about 1.4 meters. So it's a larger area. Heat and velocity hazard area going through is much higher. The other thing you have to be careful about here with the engine is if you're working on it or you're having to go into the entry-exit corridor, there's only one way that you can go into it. But make sure that you have positive communication between whoever is running the engine and whoever is using that corridor. It's mandatory. I don't know if any of you have ever seen an individual go down the inlet of an engine. I have. When I was working in the test cell area, we had an individual go down an engine, get sucked up to the inlet portion of it. Luckily, if you call this lucky, it was the type of engine that had an older engine had the inlet guide vanes that were in front of the first stage of compression. So the individual hit that, and essentially all he did is he lost his arms in that particular case, so he didn't die. But it happens. So make sure that you supply the sufficient amount of caution and ensure that you have the communication with whoever is running this engine on that. So just be aware of that. Appropriate ear protection. Make sure you have the appropriate ear protection when you're looking when you're working around the engine. Always do that. I know that some of my hearing is gone because I would be when I worked the engine test cells, I would be underneath an engine making an adjustment on the fuel controls, okay, on that area. So it is real. Make sure you take good protection of your ears on that, okay? Cowling. We have the fan cowling and the thrust reverser cowling. The parts that we're looking at here, of course, is your inlet cowl, the fan cowl, and the thrust reverser cowling. Fan cowling is going to have on the left side, you have the start valve access port for it. This port is the manual access in case you need to manually open or close the start valve. We'll talk more about that when we get into starting. The IDG access door is located on the left side of the engine, on the left fan cowling. There are 3 latches on the bottom of the fan cowling. We'll look at those latches in a minute. On the thrust reverser side, there are 9 latches that hold the thrust reversers down, okay? On the right side of the engine, we have your T12 access panel on top, okay? And because we know you are going to drop a tool, there's going to be a drop tool access panel on the bottom of the fan cap in this area right here, so that you can get that socket out of it. On the right side of the fan casing, you have the oil tank access door, so you can service the engine oil tank. The chine, okay, the chine that's on the fan case, and then on the thrust reverser on the side, we have our deflectors for the flaps for that side, so that's right there. Your piling, you have the thumbnail fairing, your mid-strut fairing, and the over-the-wing fairing area right here. The thumbnail fairing also includes a pressure relief door, okay? So that's the areas that we have as far as cowling is concerned. Opening interference with the cowling, make sure, as you can see right here, you can see that the inboard flaps portion can in fact contact the engine cowling, so make sure that you're aware of that when you're either opening the cowling, or when you're moving the flaps, make sure that you're very much aware of that. And then the same thing on your outboard side of the system, okay? Fan cowling latches. Now the fan cowling latches and the hold open rod assemblies and the spring assist rod assembly things that you have to be aware of here, and we'll look at that. But we had since this fan cowling, it's quite a bit larger than the CFM. It's awkward when you're opening it. It's heavy. It's flexing and whatnot. The spring door opening system or hold open system is there to assist you in opening that fan system. So what they're going to do is, as you're raising the door up, when you get up to about 61 degrees, it's going to lock in place and then hold it up in that area to prevent it. But it's going to take a little bit to hold it up. When you are closing it, takes two people. You're going to unlock it. One person's going to you're going to then slowly lower it, and when you lower it down, you're going to ensure that it's aligned up and put in place. There have been some new items installed onto the fan cowling to help ensure that you're actually lining it up properly. There's some other things that have changed in the fan cowling. You do not have this page in your book. I just added it because we just updated it. It's just updated on that particular piece. On the bottom, well, first of all, we have a new indication system. There's a latch indication system that's coming out of the oil tank access door. And what happens when you open the oil tank access door, you reach inside and you pull this latch indication system out in that direction so that it looks like this. What that's going to do is cause a teleflex cable that's coming to the mechanical portion that's on the inside of the cowling, and it's going to rotate this center blade. Okay, so when you pull it out, it is going to rotate the center blade, so this blade then it goes to the open position as shown here. So you pull that handle, it's going to rotate this blade then rotates out of the way, and then that gives you access to the latch for the center latch. It's not on the forward or the aft latch, it's only on the center. Okay, when you unlatch it, you have your latch handle release, then you have your latch hook and your latch pin, and you're able to release it. You have the latch extended handle. It is colored bright orange so that it is a high visibility handle, so that tells you that the fan cowling is not latched. Okay, both of these are also for the pilots for their walk around. Okay, when they go and check the engine, they can bend down and look to see that all of these are in fact not hanging down. They can also tell by the oil tank access door if the center latch is latched and closed. You cannot close the door, obviously, if that latch is not closed and this portion has been pushed back inside. So those have been added. This was added to ensure that you have a positive indication that the door or the latch is in fact closed. Okay? The hold open rod assembly, just two position, it's there to hold open the system. But the spring door opening system, okay? This spring door opening rod, that has a spring inside it that is under high pressure. It's under high pressure, you have to follow the AMM exactly in order, when you remove and replace this door opening system. Okay. First of all, you do not remove it until the door is in the full open position as shown here. What that does is allow the spring door opening rod to be fully extended. That allows the door to the spring opening system to be fully extended, and the pressure on the spring is no longer there. Then you can remove the rod, the bolt that's holding the front portion of it, and remove the back portion of it without any danger. What has happened is some people have, when the door is first unlatched and you have a little space here, and this rod, the bolt portion is right here at this point because you haven't moved the cowling up. There was instances where some people had removed the bolt, and of course what's going to happen then is all of a sudden you have the rod, it's not restrained anymore, and you're going to allow that spring to essentially extend rapidly. That could damage the fan cowling, or worse, it could damage you. Okay, so make sure that you follow the AMM procedures exactly. So we've been in here for about an hour. We're in a new section at this point, so why don't we take about a 10-minute break. It's 5:08 for me, and then whatever time you have at someplace else, come back in about 10 minutes, okay? Thank you so very much.